So far, everything we've done has been read-only. And while it's very interesting, it doesn't make for a very good chat application because you can't actually send a message to anyone right now. So in order to do that, we need to think about how we're actually storing our data, and S3 is really not going to work for us. So we're going to move to DynamoDB in this section. DynamoDB is a NoSQL database that AWS provides, and we'll talk a lot about how it works and what a NoSQL database is and why we're using it. By the end of this section, you'll actually be able to send a message using the chat app, so that's a pretty big step for us. So let's get started.
So far we've been using S3 for our data storage, but that's probably not the best choice, given that we want to be able to update and read and change these values dynamically at large scale. So one popular option in AWS is DynamoDB for this sort of a thing. Let's go over what DynamoDB can do. Now, one of the primary descriptions of DynamoDB is that it's a NoSQL database. Now, NoSQL started off meaning non-SQL, but as SQL-style interfaces started to emerge and develop on top of these databases, it became more of a not-only SQL. So a bit of a retcon there. But basically, these are not your classic databases. Most of them use a simplistic set of APIs to access the data rather than a complex query language. And some have adapted to use SQL or subsets of SQL just for a familiar way to access the data, and DynamoDB does have some of that. But you're not going to be writing complex SQL statements with joins and things like that, generally speaking. Now, most NoSQL databases are really just big distributed key value storage systems. That's the key to their speed. And the key is usually a string of some sort. And determining how to create that key is a really important part of using NoSQL databases. The value part tends to be structured, but not strictly so. What that means is that the value is stored like a simple map, but the keys and types within that map are not usually strongly enforced. Especially in DynamoDB, the table schema has no information about the attributes of the item. It's really up to the client code to consistently treat attributes in the same way. Now, most major SQL databases have strong ACID guarantees around transactions, and if you're not a database geek, ACID stands for atomicity, consistency, isolation, and durability. And basically it means that when you make a transaction into a database, you can be guaranteed that it's been written before you actually get a response back. Now, really the key to NoSQL scalability is that it doesn't provide those guarantees. If you write data into it, there's a really good chance that it will write it successfully, but it might not be immediately, and you have to be able to live with that. And often that's a valid trade-off to make because the speed and the scalability that a NoSQL approach gives you is worth giving up some of those ACID guarantees. Generally speaking, NoSQL databases provide parts of the ACID guarantee, but most of them really don't support transactions at all, and certainly not across multiple tables. So while you would be able to write a bunch of data to multiple tables and commit it all at once in MySQL or Postgres or Oracle or any other major SQL database, most NoSQL databases can provide none of these guarantees on more than a single record at a time, if that. But again, that's the price we pay for the scalability and speed of a NoSQL approach. Now, because NoSQL databases are relatively simple and don't have transactions, they tend to scale really well. So for example, there's no limit on the size of a DynamoDB table. You can also just provision a lot of read and write capacity on this essentially unlimited table. Just keep throwing more and more disk and more servers at it, and you can scale this thing out to be as massive as you want to. Let's talk about tables in DynamoDB. So DynamoDB tables are key value records, but they have a little more structure to them than that. There are three parts to any DynamoDB record, or item as they're called in the documentation for DynamoDB. One is the hash key. And the hash key, also known as the partition key, is the first part of the key. You need to have a hash key in your table. If you only have a hash key, then they have to be unique. Then you can have a sort key, which is a child of the hash key. So within a hash key, you can have a bunch of items with unique sort keys. And then we have the data, which is the rest of the record that contains the attributes for the record itself. Now additionally, DynamoDB has the ability to create secondary indices on tables. And a secondary index exists on top of an existing table, and it looks exactly like a table. It has a hash key, a sort key, and data. And you can choose what data to copy into the index. So if you need to access a table in multiple ways, you'll want to create a secondary index, and we will actually do that when we start using DynamoDB in this course. DynamoDB has a bunch of different supported data types. They also choose somewhat obtuse names for these types, so this table is basically your cheat sheet for helping us disambiguate the names with what they really represent. Several of these types have a set type, And since this is not a traditional relational database, you can actually have multiple values for the same attribute on a single record without having to do joins or anything. That's what set types are all about. So let's take a look at some of these types. B and BS, what a terrible name. Interestingly, you can store binary data in DynamoDB, but it's important to understand, though, that the data is stored as a base64 encoded string. This means that you will use more storage than the binary version of the data because base64 encoding isn't as efficient. So while it's cool that you can store binary data in DynamoDB, don't do it because you think you're going to save space. In fact, it's quite the opposite. Bool. You can store individual Boolean values. Now, storing a Boolean set doesn't make a lot of sense. You may as well just use a list of Booleans if you need multiple Boolean values, which brings us to L and M, which lets you store lists and maps in attribute values in DynamoDB. Now, maps are basically like mini records without a key, and lists are, of course, just lists of values. Each value can have whatever type you want, so you can mix and match different types within a list. That's totally okay. Then we have the number type. Of course, you'll need to send these into the API as strings because we're dealing with things in a JSON interface, but they are treated as numbers within DynamoDB, especially when used as a sort key. Finally, we have basic strings and sets of strings for dealing with textual data. For getting items back, there's a few ways to do it out of DynamoDB. One is the getItem interface, and that's the simplest way to get an item. Just provide the key to it if you know it. So if you know the full key, this is definitely the simplest and fastest way to get the item back. The result will be a single item, or if that item doesn't exist, you'll get back an error. Then we have a query. So if you know part of the key, you can try to do a query. Queries always require a hash key, so if you don't have a sort key, there's no reason to do a query because you can just do a get if you already have the hash key. You can also provide a constraint on the sort key, so you could do something like retrieving all of the items where the sort key is above a particular value, which can be handy. And you can also provide a filter, which DynamoDB will provide after it satisfies the key constraints and before the results are returned. And if you really don't know the key, you can just do a scan. And it's best to equate this to a relational database's full table scan. It will look at every single record, and it will use all the read capacity that goes along with that. And as the records are pulled, the filter you provide will be applied to determine what gets returned. So kind of a brute force approach there. You definitely want to avoid scans whenever you can if you care at all about performance and scalability. But it's there when you need it. Let's take a minute to talk about pagination. So in a regular database, you might select a fetch size on your database connection. And if you want to do UI pagination, you would use limits and offsets to configure a page of results. DynamoDB doesn't do that. What DynamoDB does is load up to 1 megabyte of data from the data store when satisfying your query or scan requests, and this is pre-filtered data. So in the case of a query, it's based on the key, but a scan will go through your entire table 1 megabyte at a time. And when you get back a result set, you may get a description of the last key processed. And this can be used to set an exclusive start key on the next request to get the next chunk of results. Now the start key is exclusive because it is not included in the result. That's because it was included in the previous result. And since filters are applied after loading the data, it's completely possible that you get no results in your result set and get a last key process. This is because your filter may eliminate all the records that were loaded. Now, when you create a DynamoDB table, you set the capacity you want. You set different read and write capacities so you can tune your table to your own use case. Let's talk about read units first. One read unit will allow you a consistent read of an item up to 4 kilobytes in size per second. If you do eventually consistent reads, you can do twice that. DynamoDB gives you the option of how much consistency you want, but you have to pay more to do immediately consistent reads. And as far as write units go, writes are a little more expensive. A single write unit allows you to write one item up to 1 kilobyte per second. So with this understanding of capacity units, you can start to see why avoiding scans is important. You don't want to burn all of your read capacity doing a single scan that returns a small number of records. This is why table design is so important. And that's the basics of DynamoDB. It's a lot, but it will become second nature once you start using it, which we'll do soon. So you probably have a lot of questions at this point, but bear with us because once you start to get your hands dirty with DynamoDB, I think it's going to make a lot more sense. So let's move on.